Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Yeah, we continue our class today and this week. And especially this week, we arrive at the topic of some continuous probability distributions. Last week, we already discussed about the discrete probability distributions, and some of you already explain differences between the continuous and discrete distributions. Okay, allow me to explain about more deeper about the continuous probability distributions. And the motivations of discussing continuous probability distributions actually we can start from these equations. Why this? Actually, this one and this one we can call as a continuous probability distributions. The answer is because the random number actually at the x-axis here along the spectrum of x-axis you can see there is always be a value for its probability. You can see here that along the spectrum there is always a probability. It means that always a value here. What is the probability? What is the density of this this axis? Actually, same also with this graph. You can see along this 1 and 3. The always value, probability value, we can say as a probability density functions. There is always a p density. There is always a density that exists along this spectrum. For example, along this 1 and 3. For this case, is from minus infinity to the positive infinity. What the important parameter to be known in probability distribution? Actually, not only continuous, but also discrete and continuous. In probability distributions, at least there are two parameters, which is mean and the variance. Please remember, every probability distribution functions should consist or reflects the mean and the variance. What is the mean? What is the mean? What the variance? What the means? What the variance? Because when we're talking about the random number, usually people asking about the average. People asking about the differences between the data. The differences representing can be represented by its variance. Okay. Then there are many continuous distribution. The first is normal distributions. Normal distribution is a continuous version of binomial distributions. You remember that the binomial distribution we already talked last week, and sometimes This normal distribution we can say as Gaussian distributions. And again, the normal distribution should have at least two parameters, mean and the variance. You can see here with the mean and the variance, we can express probability function, let's say fx. You can see here, this is the expression of normal distribution with mean m, mu, and the variance sigma. And the pattern or the form of the graph is being like this. It's like a bell shapes. With the mean here and the variance. Yeah, actually the variance it's a bit, it is cannot directly determine from the graph. You should compute actually, or should be say, should be say. You should determine. I mean, we from the only the figure of this graph, we cannot easily determine for the variance, but for the mean we can easily. Actually, the mean is from the normal distribution. We can determine by looking at the peak of the graph, and then after determine the peak, and then what is the value at the x-axis. That's the mean of the normal distributions. Okay, so again we can say at least to determine the normal distribution, we should have the variance and the means. Okay. Okay, and then what's happened with the mean and the variance? What happened with the different mean and different variance? You can see here, for example, we have a different mean, which is given by the mu1, mu2, mu3, which is mu1 greater than mu2 greater than mu3. So it reflects to the figure here. If the figure located in the same axis, x-axis, this is a M3, which is the most left. Why the most left? Because M3 is smallest, and then the medium is mu2. That's why here is between mu3 and mu1, and the most right, that is the greatest one. So it's located at the left, at the right side, the most right, the most right. Also, it is represent that mu1 is greater than mu2 and mu2 greater than mu3, something like that. And then for the effect of difference variance, we can see from the tree graph here, from sigma 1 greater than sigma 2 greater than sigma 3, you can see the most or the greatest value of the variance, we will have the graph being the 0, means that the peak is lowest, lowest compared to the variance 2. This is on the middle, and then variance 3, this is the highest. You can see. So another way we can say that the smallest variant, it's mean that the sharpest peak, the sharpest the distributions. Okay, and then when we're talking about the normal distribution, we also can compute the probability. The probability, yes. Compute the probability. For example, given normal distribution function as in figure here, compute the probability for maximum x is 0. Maximum x is 0. It means that mathematical expression is being like this, the probability x maximum 0. So the x should be include 0. That's why the x is less than or equal to 0. Probability for x less than 0, it means that the 0 doesn't include. So it should be x less than 0. The expression is being like this. Something like that. And then how to solve this problem? You can compute using integration. Actually, using integration for the probability of x less than 10, it means that integration between not between, yeah, but from minus infinity to the 0 of fx dx. Yeah, you can solve, you can substitute here. And then you can finish by integrating these mathematical expressions. And how about the second one? Actually, the second one, probability x less than 0, it means that the 0 doesn't include. So we cannot use like this, yeah, 0 fx dx. We cannot use like this, but otherwise, because 0 doesn't include, it means that we 0 until positive infinity fx dx, but this is minus. Yeah, it means that yeah, you can see here it's different how we compute. Yeah, it is different. Yeah, it's different. Yeah. Okay, using table. The second way is using table. Actually, the table names is standard normal table with mu equal to 0 and the variance equal to 1. We should, yeah, you should precisely using this table with this mean and the variance value being 0 and 1. So let's find the table on the internet. Yeah. Okay. Standard normal distributions. We can search. Can you see? Yeah. Okay. So for the okay, for the x less than 0, yeah, in this case is the x equal to be z. Yeah, z. Z less than 0. Okay, let's search 0. Okay, 0. You can see here, yeah, 0 minus 0 and positive 0 is the same, right? 0, 0, 0. So it's equal to 0 0.5. Yeah, it's equal to 0 0.5. Yeah, 0 0.5. So back to the PowerPoint. So you can see here using table for probability x less than 0 is 0 0.5. Yeah. How about the probability of x less than 0? X less than 0. Back to the table. So area to the left. Maybe this one is good. Eh. So you can see here. Maybe I will explain again about this one. Okay, for x less than 0, so it's mean that the probability of under maybe this area, yeah, from minus infinity to the sum 0. So in this point, at this point, so you can see here is 0 0.5. Okay, I hope it is clear. And then for x less than 0, let's see whether we can calculate using the table or not. Yeah. So so it's kind of minus integral 0 until positive, yeah, infinity, and this is fx dx. Okay, that's for the x less than 0. So let's find another table. Maybe we can use the calculator. Okay, when we use a calculator, particularly for the probability x less than or equal to 0, probability x less than or equal to 0. So here we can write the x is being 0, the mean 0, and the standard deviations. Actually, standard deviation is square root of variance. So we can execute. Okay, you can see here, this is the lower cumulative. You can see this is the lower cumulative 0.5, and the upper cumulative, yeah, x to the positive, yeah, positive infinity is 0.5 as well. So in this case, fortunately, this probability is equal to the something like this. Okay, I hope it's clear using the calculator. Computing this one using table is a bit difficult. Okay, and then we back to the PowerPoint. So we done using all of the technique, using integrations, using table, and using calculator. But we realized that this expression and this expression is fortunately equal. But in certain case, I mean, if you are computing the how to say in discrete probability distribution, this expression and this expression will be not equal. Please make note about this result. Yeah. Okay. Anyway, before we going to the exercise, is there any comment or any questions?
Sir, I have questions, sir.
Yes, please.
I still don't understand how to read the table.
How to read the table? Okay.
Yeah, for this normal distribution.
Okay, good. Let's back to the table. So, for example, we want to compute the probability. Wait a moment. For example, compute the probability. For example, given mu is equal to 0 and the variance is 1. Compute the probability x less than or equal to 1.2. Yeah, that's until this point. Can you understand, Hanif?
Yes, sir.
Okay, and then mathematically, given these probability expressions, it's kind of integration from minus infinity to the 1.2 fx dx. Okay, until this point, okay?
Yes, sir.
Okay, good. And then it's mean that given the integration, it's equal to find the area under the graph until 1.2, okay? 1.2. So for example here, so okay, the question is actually what is the result of integrations? It is equal to the what is the size area under the graph, this one. Okay, the table tells this table specifically tells that the mu equal to 0 and the standard deviation equal to 1. Usually the characteristic of this table is following this value, and then we can easily find the point 1.2. So this one, right? 1.2, 1.2, and because there is 1.2000, so after the 1.2 is 0, so we put like this, and then we got this one.
Excuse me, sir.
Yes.
I think you haven't showed the table yet because
Huh?
in my screen it's still
Oh,
the
really?
PowerPoint. Oh. Yeah.
I'm sorry. Oh, yeah. Sorry. Okay. I repeat, yeah. For example, given the probability being the mean is 1, and then standard deviation is mean 0, standard deviation is 1. Okay, can you see now?
Yes, sir.
Okay, and then find the probability x less than 1.2. Okay. And then mathematically, we can compute using the integration. The expression is being like this. Integration from minus infinity to 1.2 fx dx. Okay? Ff dx. And then you remember that the pattern of the normal distribution is like a mountain, right? Something like this. So this integration is equal to the finding the size area below the graph. It is 1, let's say in this point is 1.2. So what is the area, size of area under the graph? So if you done using integration, that's good. But if it is too complicated, so we use the table. So since the 0.2 we see here at the column, you search 1.2 here. Okay, can you see? Okay, and because 1.2000, it's mean that after 1.2 is 0, so we put here. We pick up this one and straight down. So the intersection is here. So the result, the probability of x less than 1.2 is 0.8849. It is makes sense by looking at this area, because if you slice at the middle here, half of the slice will be 0.5 The another one is 0.5. So 0.5 plus area this one, so it's exactly around this point. Is there any questions? Is it clear?
Sir, so the 0.00, is that the mean?
0.0.
What is that? Yeah, that's
This
that
one.
one. Yeah.
This one is because of 0.2. After 0.2 is 0, 0.
Okay. Like the
Okay.
digit after the 0.2.
Yeah. Okay.
Oh, okay. Okay, sir,
Let's
thank
make
you.
it clear again. For example, if probability x less than 1.22, you should find this one for the row and this one. So yeah, 0.2 and 2. So we should draw here like this. Yeah. Okay, you got it. Okay.
Okay, sir.
Okay, yeah.
Thank you.
Please make a note. We want to check. Yeah, please. So it's 0.88. Okay. Is that true or not? Maybe I'm wrong. So it's also possible. So I will check using the calculator. Okay. Calculator. So you can open this one and then please remember this is the result should be 0.8888 4 times. So in this case should be 0.22, right? And then execute. Okay, that's the result. Why we choose the red one here? Because this is the lower cumulative. You should look at the mathematical expression here. You can see the integration is from minus infinity to the x. So we should take this result, yeah, 0.8888, and this is a round up, yeah. So the result is correct. The table and the calculator. Okay. Any questions? Can you see the online calculator? Can you
Yes,
see?
sir.
Okay, good.
Sir, I have another question. If the mean and the standard deviation is different, for example, like the mean is 2 and the standard deviation is not 1, can we still use the table?
No.
So the table only for mean equal to 0 and the standard deviation is 1.
Yes, actually the table usually the table only for the mean equal to 1 and the standard mean is 0 and standard deviation is 1. This table is only for this characteristic, this
Okay, sir.
value. Okay.
Okay, thank you.
Okay, yeah. Okay. Okay. I have an exercise here. Please everyone compute this exercise for first and the second. Maybe you have until 5 p.m. yeah, until 5 p.m. Okay. I have shown right for this screen. Okay. Okay, I have an exercise here. Please compute and or conduct this exercise by yourself. and until 5 p.m. 5 p.m. Okay.